Compound angles. Before we explain the concept of compound angles, let's simplify these three. Angle A is 70, angle B is 50 degrees. Cos of A minus B is going to be cos of 70 degrees minus 50 degrees. And this is equal to cos of 20 degrees. Using your calculator, this becomes 0.94. Cos of A minus cos of B means cos of 70 degrees minus cos of 50 degrees. And if you calculate this using your calculator, you'll get minus 0.30. The third one, cos A times cos B plus sin A sin B is equal to cos of 70 times cos of 50 plus sin of 70 degrees times sin of 50 degrees. Simplifying this with our calculator, we get 0.94. Can you see that this is exactly the same as our answer in number 1? It therefore looks as if cos of A minus B is equal to cos A cos B plus sin A sin B, and not equal to cos A minus cos B. Remember a few important things here. This bracket does not imply multiplication. This means cos, a function, of an angle, the angle between the brackets. We're talking about compound angles because this angle is compounded, substituted, made up of two angles, A and B, and there is a calculation between them. In this case, subtraction. Do never think that this means cos of A multiply with negative cos of B. That was number 2. You can see the answer is totally different. The first formula for compound angles is the one you see here. Cos of the difference between two angles, A minus B, is equal to cos A times cos B plus sin A times sin B. This formula does appear on your formula sheet. However, I want to urge you to memorize this. It makes it a lot easier and a lot quicker in a test or exam. Use your formula sheet to check yourself. The first formula for compound angles was this cos A minus B. We can also get cos of the sum of two angles, and this is cos A times cos B minus sin A times sin B. For sine, there also exists compound formulas for the difference between two angles, which is sin A cos B minus sin B cos A. And the second is sine of the sum of two angles, A plus B. So that becomes sin A cos B plus sin B cos A. These are the 4 compound angle formulae, and they appear on your formula sheet exactly like this. Let's apply this down here below. First one, sine of x plus 50, is the last one. It's a compound formula, sine of x cos 50 plus sine of 50 times cos of x. The second one, cos of 30 degrees plus 3x, is that second formula. So this becomes cos of 30 degrees times cos of 3x minus sine of 30 degrees times sine of 3x. The third one, sine of p minus 3q, third formula. This will be sine of p times cos of 3q minus sine of 3q times cos of p. The last one, cos of 60 minus 2x, that's our first formula, becomes cos of 60 times cos of 2x plus sine of 60 times sine of 2x. Let's simplify these expressions. Cos x cos y plus sin x sin y is a cos cos sin sin formula. In other words, it must be of one of the cos formulas up above, and because there is a plus, we select cos of a minus b. So this becomes cos of x minus y. 2.2 doesn't look at all like any of the formulas above, but if you look carefully you'll see that cos a times sin b seem to have just been swapped around. Remember, there's no difference between cos a times sin b and sin b times cos a. So let's rewrite it as sin b times cos a minus the rest sin a cos b. This part now looks exactly like formula number 3. So this reduces to sine of the difference between b and a, sine of b minus a. 2.3 is once again a cos cos sin sin expression, so it's equal to one of the top two formulas, and in this case it will be cos of 50 degrees plus 40 degrees, and that we can write as cos of 90. 2.4. The first thing we must do here is to rewrite those angles that are not acute, not in the first quadrant, as angles in the first quadrant. So cos of 350 lies in the fourth quadrant. Cos is positive there, so this is equal to cos of 360 minus 10, which is just equal to cos of 10 degrees, times cos of 80, which is acute, minus sine of 170. 170 lies in the second quadrant. Sine is positive there, so this is 180 minus 10 degrees, so we just write it as sine of 10 times sine of 80 degrees. Now, we have a cos cos and a sin sin expression, and this is equal to one of the first two cos compound formulas, and in this case it's equal to cos of 10 degrees plus 80 degrees. We can again write cos of 90. 2.5. This looks very strange at first glance. Sine sine subtract sine sine. There is no such formula up here. But remember, there is a relationship between sine and cos. Sine and cos are each other's co-functions. So we can take any of these sine ratios and rewrite it as a cos of the complementary angle. So sine 80 is cos 10, sine 40 is cos 50, whatever you want to do here. So let's have a look. If we start by keeping the sine 80 exactly like it is, then we have a sine ratio and we are looking for a cos ratio. So sine 40 we can write as cos of 50 degrees. Minus, by now we have established that the angles we are working with is the 80 degrees and the 50 degrees. So we already have a sine 50, so let's write that down now. So minus sine 50 times, and the sine 10 degrees we must change. So we use the co-function there to cos of 80 degrees. And now we only have two angles, 80 and 50 degrees, and this looks very much like the third formula. So we write sine of 80 minus 50 degrees, which is equal to sine of 30 degrees. There is an alternative way of doing this. Instead of changing this formula to sine cos, let's change it to cos cos, sine sine. Sine of 80 degrees in terms of cos is cos of 10 degrees, and sine of 40 degrees is cos of 50 degrees. And now we can see 10 and 50 is already the angle represented on the right hand side, so we leave the right hand side as it is, minus sine of 10 times sine of 50 degrees. And now what do you see? We have formula number 2. So this becomes cos of 10 degrees plus 50 degrees, which gives us cos of 60 degrees, and cos of 60 is sine of 30 degrees. Can you see that sine 30 here and sine 30 on the left hand side are exactly the same?